My name's Nitin. You're going to hear a talk about an open privacy research toolkit. This is joint work with Professor Paul Laskowski, and if you have any questions, just let us know.
Hi all, my name is Nitin, and I'm here to present work with Paul Laskowski on an open privacy research toolkit. What we want to do in this project is enable social science research to be done on rich data sets that hold personal data. So the fundamental question we're considering is, how can we let researchers study such data sets? There are many strategies to enable research on data sets that include personal information. One such strategy is to allow predetermined summaries to be released to the public. These have pros and cons. One pro is that it's quite actually cheap to release this information in terms of the ease to compute. However, it's not flexible for all types of social science research that a social scientist might want to do, as the queries are determined beforehand. Another alternative is to use popular privacy techniques such as differential privacy. So while this is more flexible than releasing predetermined public summaries, not every query a social scientist want to ask can be answered in a differentially private manner. Furthermore, there are certain development costs that a social scientist would incur by having to change their script in order to satisfy differential privacy. This requires specialized knowledge of differential privacy, as well as other development skills as well. A third alternative is what we can call screen and trust. These are ones where we would actually screen the folks who we're allowing to run queries on a data set. Now, this is the most flexible thing that somebody could do because we could allow them to run arbitrary code. However, this requires screening folks and a lot of other administrative tasks to make sure that we mitigate the risk of a privacy breach. So these three strategies that are currently used have trade-offs between flexibility and the cost of actually computing the statistics they want. So one thing we're interested in is considering the following. Wouldn't it be great if we could just submit an algorithm to a system, have the system treat it like a black box, and in this manner, study how sensitive it is to its outputs? From that, the system would be able to add noise accordingly to meet some privacy guarantee. This system that we envision is called a privacy wrapper, explained through this following diagram. So we have a researcher. She submits a script to the privacy wrapper. This script wants to answer a question in a privacy-preserving manner, but the script isn't designed to meet that guarantee yet. So what our system would do is actually analyze the script and see how sensitive it is to certain inputs and outputs to determine the privacy noise that's needed to be added. From then, our system would be able to release a private answer to the script to meet this privacy level. Now, this is what we want to do with the privacy wrapper, and there are a few points that are worth mentioning here. The privacy wrapper actually has to utilize noise, because otherwise particulars of an individual could be leaked through the output. A second thing that's worth pointing out is that the privacy wrapper must have a privacy guarantee that's probabilistic. And what we mean by that is it's worth noting that differential privacy won't work in this case for our privacy guarantee. Because the researcher is allowed to submit a script that could be arbitrary, it could have unbounded sensitivity. And as such, we won't be able to actually add sufficient noise to protect the presence or absence of any one individual. So this suggests that we will require a privacy definition that allows for a privacy bound to be met with high probability. So this is the point of our privacy wrapper. We believe that our privacy wrapper can allow for analysis of rich data sets without having to have social scientists alter their work practices, and while still allowing for strong, provable privacy guarantees in the process.